part of extraction of metal. So I'll be sharing my screen right to my whiteboard where I'll be explaining extraction of metal. Okay, right? All right. So we want to look at extraction of aluminium now. We want to look at the extraction of aluminium. That's what I want to look at. Extraction of aluminium. Now, in the extraction of aluminium, I have explained to you already extraction of iron from a blast furnace. So in the extraction of aluminium, these are the things that we're going to consider. Already I told you that the first 5 metal can only be extracted by electrolysis because they are highly reactive. Okay, I'm talking about potassium, sodium, hydrogen, magnesium, and aluminium. The first 5 metal, they will be extracted by electrolysis. While metal that we have below carbon, are extracted by reduction with carbon. And then metal below hydrogen, especially silver and gold, they exist as free elements. So all you just need is to burn the particle, and then you have the metal in its pure state. Now let's talk about extraction of aluminium now, which is electrolysis. So in the extraction of aluminium, we consider the following. What is the name of aluminium ore called? Aluminium ore in nature, in a combined state, as aluminium oxide, L2O3, and the general name for this is called bauxite. So this is the naturally occurring state of aluminium. And then the next thing is, how do we extract aluminium? How do we separate aluminium from oxygen? So I told you we do it by what we call electrolysis, a process called electrolysis. Now, in electrolysis, we have a diagram, and then in the diagram, okay, let me do this again. Let me show it properly. We have a diagram like this. So in the diagram, we have our during electrolysis, and then we have it connected to electric source, the battery. Now, I'm trying to show us the setup of electrolysis where you want to extract aluminium from aluminium. Now, the two electrodes you use, the electrode you use for this electrolysis, the name of the electrode, please take note. Name of the electrode for both anode is graphite, you use graphite. On the cathode as well, you use graphite. And please do not forget, graphite is carbon. Carbon can exist as graphite. Carbon exists in different forms. So carbon can exist in graphite, diamond, charcoal, and so on. So when we say graphite, we are saying carbon. So the anode, let's identify our anode. Our anode is positive, our cathode is negative, and they are made up of graphite. So take note of that. And then, of course, the bauxite is your electrolyte. The bauxite is the electrolyte, that is molten state of Al2O3. And then you run your electricity. When you run your electricity, you notice that aluminium will dissociate. Into aluminium ion and oxygen ion. Now guess what? Aluminium ion, which is the positive ion, otherwise known as cation, will be attracted to the negative. You know that in physics, unlike charges attract, while like charges repel. So negative attract positive, and then positive attract negative. So oxygen will be here, So the next thing for you to take cognizance of is that the reaction that happens at the anode and the reaction that happens at the cathode. All right. So we call that anodic reaction. During the extraction of aluminium, they will ask you, state the anodic reaction. Anodic reaction is the reaction that takes the anode, and the thing is what you write. Now, at the anode, we have oxygen there. So oxygen will be discharged. How do you discharge oxygen? Now, when we have oxygen 2-, that means oxygen has excess electron, which is additional 2 electrons. So for oxygen to move from a charge point to a neutral point, 2 electrons has to be given away, and then we have something like balance. So these are we discharge oxygen at the anode. Please take note of it. We've talked about it during electrolysis. Now, what about cathodic reaction? So at the cathode, the reaction that takes place at the cathode, so you write cathodic reaction that happens at the cathode. Now let's go again. Which ion is at the cathode? Aluminium. That is cation. Aluminium. So you write aluminium has lost 3 electrons. That's why you call it 3+. So you are positive when you have given away electrons. So 3+. Now from aluminium to transform from a charged state, which is 3+, to a neutral state that is not charged, it has to collect 3 electrons, and then aluminum become neutral. All right. So you don't need to balance. This is balance. So this is the cathodic reaction. Now, what else can be asked? Now they can ask you, okay, now what is the overall reaction? Overall reaction is a reaction whereby you combine anodic reaction and cathodic reaction together. Overall reaction. Now, how do you do that? You combine what? You combine the anodic reaction and the cathodic reaction together. So I want to combine anodic reaction and cathodic reaction together. What I'm trying to say is that I want to combine this, I want to combine this, and I want to combine this together to give me overall reaction. Now, for you to do that, you look at the electron. Look at the electron. The electron here is 4. The electron here is 3. Now, when you have the electron here 4 and you have the electron here 3, what is that number that I use to multiply 4 and 3 so that they can be the same? So we do this. So we say this one times 3, while this one times 4. Why are we doing this? By the time you multiply 3 times 4, you get 12. You multiply 4 by 3, you still get 12. So 3 and 4 are the number that we use to multiply this electron and this electron so that they can give us the same thing. So to combine anodic reaction and cathodic reaction, we have to multiply anodic reaction by 3 and cathodic reaction by 4. This is how we go about it. So we go like this. 3 times 2 in oxygen, that is 3 oxygen ion. 3 times 2, that is oxygen atom, that's 3 molecules of oxygen. And then our, what is it called now? Our electron, 3 times 4 electron, that's 4. That's 12. 12 electrons. Alright, so we go again. 4 times aluminium, that is 4 molecules of aluminium ion. And then 4 times 3, that is 12. Okay, no? That's 12. That's plus 12 electrons. And then we now go again. 4 times aluminium atom, that is 4 aluminium. Now, after doing this, we will now write all the reactants. What are all the reactants? These are all the reactants. But you know what? The electron on the anodic side has come to the electron on the cathodic side. So we are writing only oxygen ion plus aluminium ion, and then that's the reactant. And then on the product side, we write oxygen and aluminium. So 3 molecules of oxygen plus 1 molecule of aluminium. So this is the overall reaction. This is the answer that you give as what? As overall reaction. So in the extraction of aluminium, let me bring all this together. In the extraction of aluminium, we use electrolysis. After electrolysis, aluminium, which is the cation, goes to the cathode. Oxygen, which is the anion, goes to the anode. And then you show the reaction at the anode, show the reaction at the cathode, and then show your overall reaction. So that is the process of electrolysis. Now the next thing they ask is this. They will ask you this question, likely question. Please pay attention. Likely question. They will say, for this electrolysis to go on very smoothly, why do we add cryolite? This is the spec. Why do we add cryolite to the ore of aluminium? Why do we add cryolite? We add cryolite to bauxite. Why do we add cryolite to bauxite? That is the ore of aluminium. Now this is the answer you give. We add cryolite to bauxite in order to reduce the melting point of bauxite. Now what happens is that when electrolysis is taking place, the molten state of bauxite will dissociate. And for it to dissociate, it has to melt completely. And the amount of energy to melt bauxite is over 1000 degrees centigrade. And that is not energy, it's not cost effective. It's not, we are not managing energy that. So what we do is to add cryolite so that the energy required to melt bauxite will be very low, therefore making it economically cost effective. So the effect of cryolite is to reduce the melting point of bauxite to about maybe 950, something that is above about 1500 centigrade to about 900 or 950, and then you have saved energy, you have saved cost. So that is the effect of cryolite. It reduces the melting point of bauxite in the extraction of aluminium. Another thing they will ask is that, let's look at the diagram again. Oxygen is deposited at the anode. And do not forget, I told you that the anode is made up of what? Of graphite. And graphite is another word for carbon. So what happens when oxygen attacks carbon? They become carbon dioxide. Before you know it, the carbon at the anode will be corroded. So during the electrolysis of aluminium, we have the carbon at the anode corroded from time. And then what do? You have to change the anode during the electrolysis process. So there is a popular question that usually come out. They will ask you, why is the anode changed during the electrolysis process? The simple answer is that because oxygen attacks the anode, which is the carbon at the anode during the electrolysis process. So that's the simple answer to that. So these are all things you need to know in the extraction of aluminium. Alright, so now let's quickly move on to extraction of some other metal, which is by reduction with carbon, not electrolysis again. For example, you are asked to extract copper. The natural form of copper is copper carbonate. Now, if you want to extract copper carbonate is the natural occurrence of copper, but we don't need carbonate there, we need only copper, excuse me. So what do? You do what is called composition reaction. The composition reaction is when you heat copper carbonate and it decomposes, it separates into copper oxide and carbon dioxide. Carbon dioxide is a gas. Carbon dioxide is what? It's a solid. And the gas we do what? We escape to the atmosphere. So we don't need the gas. So we come with copper oxide and now reduce it with carbon. So because carbon is more reactive than copper, so carbon will now displace copper. A displacement reaction will occur here. Carbon will displace copper. So now have carbon dioxide. You can balance the equation by putting 2 here. Carbon dioxide plus copper. So with these two equations, we have been able to show what? The extraction of copper. Another one, how do you extract zinc? You know, zinc is by the natural occurring of zinc is zinc sulfide. This is zinc sulfide. Zinc sulfide. So you can always pause my video if my explanation is too fast and replay it so that you can get better understanding. So zinc sulfide is a natural occurring of zinc. We don't need the sulfide, so we need zinc. So what do? We burn zinc in oxygen. We burn zinc in the air. So when you burn zinc in the air, this is the equation. Now we have zinc oxide and sulfur dioxide. Sulfur dioxide is a gas and it gets escaping into the what? Into the atmosphere. So zinc oxide is what we need. Zinc oxide is what we need. So we now reduce it with carbon. We reduce it with carbon, and then we have zinc, we have carbon dioxide, and of course we have zinc. So the equation is not balanced. Let's balance. So the equation is balanced. So we have zinc solid, we have carbon dioxide and it's a gas, carbon solid, zinc oxide is solid. So with this, we have been able to extract what? We have been able to extract zinc. So this is how we can extract some metal. So far so good. I've been able to explain extraction of iron. That's class. This class we have explained extraction of aluminium. Those are extraction by electrolysis. And in addition to that, I've also shown you extraction of copper and extraction of zinc by reduction with carbon. And please write it down in your notes and always read it before exam so that I don't forget. Lastly, what I want us to take note of now is called alloy. I'm sure the word alloy is not new to you. The meaning of alloy is the mixture of a metal with another element. Alloy means mixture of metal with what? With another element. So I'll give you common alloy now. Take for example, steel is an alloy. Steel is an alloy. So what are the composition of steel? Iron plus carbon. Okay, so we have another one called stainless steel. Stainless steel is mostly used for cutlery in the house, your spoon, your knife, and so on and so forth. So stainless steel is made up of iron, carbon, iron, carbon. What are we again? Chromium, and nickel. That's your stainless steel. So let me show you the note I have sent to you on Team so that you can get more example of alloy and their components. So here is the note I sent to you on Team. Let's look at some example of alloy now. Okay, hold on. Okay, this is alloy, a mixture of metal and another element. Okay, so let's look at some example of alloy. Okay, so brass is an example of alloy. What are the composition of brass? Look at the composition of brass. We have zinc and copper. Okay, and having zinc and copper mixed together, it means that metal very hard, shining, and can be used as musical instrument. It can also be used as doorknobs and key. What about bronze? Bronze is copper and tin. So usually it is used as ornament. Okay, steel, I've told you about steel and I've told you about stainless steel. We have more alloy that are not listed. This one are just the common one. We have another alloy called soda. Soda is a mixture of lead and tin. Sn, that's the symbol for tin. So you can add that to the list. Alright, so we've come to the end of the class. My encouragement for you is that read these notes that I've sent to you on Team and get ready for CAT 1 exam, I think happening next week. Alright, so if you have any question, you can always send me an email. There's an assignment on Team that you need to do, multi-choice question, 1 to 50. Send the solution to my email. Alright, so that will be all for today. Enjoy the rest of your day. Bye-bye.